geometric series, one that does not end or where it's impossible to determine the number of terms. It is not possible to find the infinite sum of a diverging series. Because the total gets larger and larger. You can only determine the infinite sum of a convergent series. Because as the terms approach 0, the sum will converge on a total. So this is going to give us our last formula for this unit, so let's just review. We had two formulas for arithmetic sequences. We had one for Tn and one for Sn. We had two formulas for geometric sequences. We had Tn and Sn. This one is only for what we call the infinite geometric series, and that's when the R value is a fraction, because that's what makes it converging. So we start with S, but we're not going to put Sn because we don't know n with these. What we put is S and a little infinity symbol. S infinity. And we call that a sum to infinity and beyond. Remember the scary formula from yesterday? Remember that one? Oh, check this one out. T1 divided by 1 minus R. That's it. Sum to infinity. T1 divided by 1 minus R. How do you know which formula to use? Well, if the question specifically says an amount of terms, find the sum of the first 12. Find a term of the first 18. Here's a sequence with an n term. That's going to be the Sn formula. If it says infinite sum, or it just gives dot, 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 and the sequence goes on forever, or it says find the value of all of the terms, that's going to be a sum to infinity. So let's look at the straight up standard kind of question first. This one tells you in big letters right in the question, infinite. So that's why you're going to use S infinity, not Sn. The other way you'll know is if you look here, there's no n value, no n term. If it's just dot, 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 and it goes on forever, that's going to be a sum to infinity. The third way you'll know is what kind of sequence they give you. Is this converging or diverging, and how do we know? It's converging. How do we know? Because the fraction, the numbers are getting smaller, they're approaching 0. All of those three things tell you it's now going to be the new formula, not the old formula. To be honest, we're kind of happy with the new formula because it's way less work. So when we see infinity, we're like, yes, I don't have to do that scary fraction from yesterday. This is a straight up, nothing tricky, just a sum to infinity equals T1 over 1 minus R. Do we have T1? What is it? R, we have to do a little bit of work, and you don't need to show it, but I'm going to do it off to the side just so we can see. How do we find R for any kind of geometric sequence? Take any term and divide by the previous term. Would you like to use term 3 and term 2, or term 1? Term 2 and term 1, so term 2 is the 2 on 5. Term 1 is 2. What's under that 2 that we don't see, but we know it's there? How do we divide fractions? Do the reciprocal of the bottom fraction. And then top times top, bottom times bottom. And then we reduce. And I heard someone say a minute ago, 1/5. If you can see it in your head, great. You don't need to show this. But if you're visual and need to see it to understand it, then show it. There's nothing wrong with that. So the bottom becomes 1 minus 1/5. We're going to practice one without our calculator just for fun, because this could appear on the non-calculator section of your exam. We're going to do the bottom first. How do we subtract fractions? Yep. So 1 minus 1/5. Again, you don't need to show this if you can just do it. I'm just showing it in case you need to see. What's the lowest common denominator between 1 and 5? So we're going to put this one over 5, and this one's going to stay over 5. How did I multiply the imaginary 1 to turn it into 5? What did I multiply by? 5, so the top's also going to be multiplied by 5, 1 times 5. Other one stays exactly the same as 1/5. Then we keep the bottom, subtract the numerators, 5 minus 1. So we still have the 2 on the top. All we've just done right now is the bottom, which is 4/5. This is just a straight up division. My first fraction is 2 over imaginary 1. I'm going to flip that bottom guy. 4/5 is going to become 5/4. Top times top, bottom times bottom. And typically we give sum to infinities in decimal. If you want to keep it as a fraction, there's nothing wrong with that. It's just typically they're in decimal. So this would become 2.5. Let's just do it on our calculator to verify we can get it on our calculator. The only little trick is if you have the old system, you just bracket the bottom. If you have the new one, the brackets aren't going to matter. So if you have the old, you're going to hit 2, then division, open bracket, 1 minus 1 divided by 5, close bracket, enter, should give you 2.5. Now I'm just going to point out, because somebody I was talking to 2 days ago didn't know this, is do you know how to get your calculator to put that in fraction for you? Because if you don't know, this is seriously one of the best things about the calculator. So right now it should say 2.5 in decimal. Don't hit anything else, just leave that. But I want you to go to the math button, so hit the math. And then number 1, do you see there's an arrow in the word frac? Hit number 1. And so the calculator screen will say answer arrow frac, hit enter. Watch what it did. What did it give you? 5/2, which is the lowest term fraction. So if you're ever doing in decimal and you're like, ooh, the answer's in fraction, you just hit math frac. So cool. If you want to go back to the decimal, how do you ask the calculator to do that? Go to the math button, hit dec, number 2, bam, calculator does it for you. And it always reduces, always gives you lowest terms. Brilliant little machines. And you don't even know the half of what they do yet. Wait till I show you more later. Questions on like this straight up kind of calculation? It seems so easy after yesterday's mess. Okay, we're jumping right into the word problems. Read to read number 2. What is it about after you read to read, read to read, read to, after you read it? Yes, something about a geometric sequence, something probably about infinity. That's all you're going to get on the first time. Now let's pick out the key information. What's the most important in the first sentence? I would say sum to infinity is important because that tells you right away it's the new formula. Convergent really isn't as important because I've already told you it's to infinity, but it's a good word to pop out. And we know that that is 16. What else is important? Common ratio is a half. Okay, find the question word. What are we trying to find? The first term. Okie dokie. How is this example different from the first example? Yeah, we had T1 and we didn't know the sum. This time we have the sum and we don't know T1. So sum to infinity is T1 over 1 minus R. What do you want to put on the left-hand side? Do we have T1? Nope, so we just leave it as T1. Do I have R? First thing I'm going to do is this 1 minus a half. That should be able to be done without a calculator. What's a whole minus a half? A half. So I get 16 equals T1 times a half, or divided by a half. What's the opposite of dividing something by a half? Now be careful because some people think we need to flip. Why did I not flip that fraction? because I'm multiplying by it. If this was on the same side and I needed to do the 16, I would flip. But this is just a straight multiplication to cancel. So this just ends up being a half times 16, which would be 8. Okay, so if all on one side it was 16 divided by a half, then I would flip. Because it's not, I'm not going to flip. I'm just multiplying to get rid of it. So a little bit of a twist, but still a pretty straightforward calculation question. Who cares about sum to infinity? Well, here's all the different possibilities that are going to come up. Not all of them, some of the different possibilities. Read to read number 3. Don't overthink it. Just a sentence in a book. Put the context into your head. What is it about? Some kind of oil well. That's all you're going to get on the first pass. And don't forget, what your brain is doing is recalling everything it knows about oil wells. So even though you don't realize it, it's picturing them. It's recalling everything you've ever read about them. It's doing that without you knowing it. If you're trying to think of math at the same time, your brain is then fighting with each other. Now let's pick out the key information. The first number is, we need to figure out what's that attached to. What does that number have meaning for? First month. So what information is that giving you in terms of our formula? T1. What's the next number? Ooh, I want to use the word dropping. Remember we talked percentages already, and we talked about decreasing percentages? What was the little thing in red we put off the side with a decreasing percentage? It was the hot tub with the 10%. So with our hot tub question, we didn't say R was 10 or 0.10. What did we say R was? Why? Because it's decreasing. So this is taking out 5% of the oil, but how much is still remaining? 95%. So there's going to be something with that decreasing. Find the question word, how much? How much what now? Does a well ever really go dry? If you know anything about geography, it never really goes dry. There's still always a little tiny bit of oil. Not enough eventually so we can actually get it out of the ground, but it's never really going to be physically dry. What they mean by this, until we can get the last amount out. So because there's this concept of there's always going to be oil there, this is what's telling you it's going to be a sum to infinity. The other way you know it's a sum to infinity is we have no n value and no way to find an n value. And so if we don't have n and can't find it, it has to be a sum to infinity. So this is actually a straight up sum to infinity once we figured out what the question's giving us. What is T1? What is R? If you want to do it in fraction, I was going to decimal it because I was feeling a little lazy, but. So 0.95, and we're just going to make a note. That comes from 1 minus the 0.05 given in the question. So this is another decreased percentage question. This would be a calc question, so you could just throw this right into your calc, just bracket the bottom if you needed to last time we used our calc. $12.50? I think you maybe didn't bracket.
No, I did. Oh, never mind. I
Got you, okay.
forgot to divide.
Offer 500,000? Some units, because it's a word problem. 500,000 what? Oils? That doesn't make sense. Barrels. Questions so far? It's nice to end the unit with this formula because it's like 2 variables. There's not a lot to screw up. Goes into the calculator fairly easy.
I prefer 500,000.
Oils? Yeah, we like that. Somebody last year in economics, I'm not going to tell you who because they still are in the school, was writing this whole paper on fracking, right, which is how they break the ground to get oil out and how it's really bad for the earth and we shouldn't do it. And then she wrote about how oil is used in cooking and to make beauty products. I'm like, not the oil they get out of the ground. No, no. Could you imagine beauty products? Not so much. Not so much. Number 4 looks long and scary. Just read to read. Don't stress yourself out. Just read it. Sentence in a book, a boring book. What's it about? A ball. A ball that's doing what? Bouncing. So everything you know about that, your brain is bringing forward. If you're taking physics, you probably got some physics stuff going on in there as well. If you've never taken physics, you're probably thinking of your childhood when you bounce balls on something. But your brain is doing that without you asking it to. It's the first thing it does is flips to everything it knows about balls. That sounded bad. Bouncing balls. Let's pick out what do we need to know. 6. What about 6? How do we know? What tells us it's T1 in here? 80%. Does it say decreasing by 80%? Does it say increasing by 80%? So this is just going to be R. Don't overthink this. It just is what it is. Decreasing percentages are when we subtract from 1. When you're increasing a percentage, that's when we add that 1 point something in front. This is just a straight up 60%. Okay, what else? We have no question words highlighted. And like that's bolded, and well, it's not bolded, but capitalized, so you know that that's got to be really important. Until. Do we know how many times it bounces? Do we care? No, we don't care. This has to be in sum to infinity because we don't have that end value. So we need a T1, we need an R, we need a diagram. When a question asks you for a diagram, there's got to be a reason, which means it's probably a little bit different than the other examples or something different is going on. We rarely ask for a diagram when it's a straightforward question. So it tells you bouncing balls probably have a little twist to them. Not literally, although they might. But. I don't know why I want to think this is on a cliff. I just do, because I don't want a guy on a ladder. That's just weird. I don't know. Here's my little physics guy. It's Mr. Libby there on the cliff. He's got no shoes on, let's be honest. Well, it's so small, I can't put it on there. Okay. Now it looks like he has a little elf shoe on. And here's our ball, and so we know this is 6. He's got really long arms. Have you never seen them? Like super long arms. And so here's the first bounce, and we know that that's 6 meters. No, that's the ground. It's just not flat. Yeah. Exactly, a bumpy ground. Here, I'll put a flower. There. No, it'll pass right over top, because I'm a physicist and I calculated that perfectly. And what happens after it hits the ground? Okay, it comes back up by 80%. Okay, so 80%-ish. And then what happens? Goes down again how much? Still that 80%, because the height can't decrease on the way down. And then it bounces up to 80% and back down, and then 80% and back down. Whoop, bye flower. Yeah, just went right over top. Flower is safe. Okay, so let's start and see what's going to happen here. T1? Because I wasn't paying attention, thank you. Was making sure you were paying attention. T1. R. 80. 80. 0.8, because we need our 80%. Sorry? Confirm 30? So where's the trick in this one? If they've asked for a diagram, there's got to be a reason, which means there's something different about this question.
It's the total is
Oh, explain. Explain. So where's T1 in this picture? The first drop. Where is T2 in this picture? It's the second drop. Where is T3 in this picture? It's the third drop. So what have we calculated? It's the total distance the ball dropped. Is that what the question is asking us for? No. What have we not calculated yet? The ball, when it rises, we don't have this section, we don't have this section, we don't have this one, etc. What about at the beginning? It drops at 6, so I don't need to double T1, but I need to double T2 and double T3 and double T4 all the way. So grab your red pen. Bouncing ball questions are always going to work this way. The total distance is going to be twice the sum to infinity, which would double all of the terms. So what am I going to subtract off? T1. That's the trick with bouncing balls, because it goes up and it comes down. It's always going to be twice the sum to infinity minus T1, because we don't need to go up for the first one. It starts at the top. So anytime you come to a question that's about a bouncing ball, that's the little formula you're going to have to use. No, that's twice the sum to infinity. It's a S, not a 5. Twice a S infinity.
and that's the formula you use for
All bouncing balls questions. So my total distance, I'm lazy, so I just called it TD. That's not a touchdown, it's total distance. Is going to be twice times my 30, but then minus off my initial 6. 2 times 30 is, minus 6 is. Give me some kind of units. So a couple notes. If a question's asking you for a diagram, there's a reason, because it's something different than a normal kind of word problem. So if there's a diagram, there's a reason they want you to see something in it. Secondly is anytime it's a bouncing ball, you need to do the total, or sorry, the sum to infinity times 2, subtract off the first term. Number 5. Oh, it's even longer. Why are there words in math? You probably got it something about midpoint, something about a square, then you probably got bored and really scanned the last little bit. And that's okay on read to read. That's what most people do. You always scan stuff before you start to understand it. Let's get the most important stuff. Really, Anthony? Like, did you need to interrupt my lesson to show them some video on your phone? Whatever. Was that appropriate? Put it away, away, away. I'm not showing you stuff on my phone. Though I could, but I won't. First sentence. Definitely midpoint, that's a good mathy word. Sides of the square. Ooh, join to form new square. Inside the first one, all of that is pretty much important. The minute you see infinite tells you what formula you're going to use. So already you know we're going to have a sum to infinity somewhere in here. This is one of these questions that unless you've seen it, you would probably not know how to do this in the real world. So that's why I have an example that's very similar, because there's probably going to be one similar in the homework. I am a ruler person because I am left-brained. I cannot stand little snaggly, yucky drawn lines. If you are left-brained, at the front, there's always a blue box of rulers, so help yourself if you want one. Sometimes I'm too lazy to walk up there. I grab the side of my calculator, the side of my phone, side of my calculator, side of whatever. If you like snarly, nasty lines, that's fine in your notes. Don't do that on the test. That just makes me angry. We draw nice lines on tests, nice ruler lines. I'm going to just estimate midpoint, 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 midpoint. I'm just eyeballing it. I could measure and mark it. I'm really too lazy at this moment to do that. I'm just eyeballing it. So that's the midpoints of the sides of my square. What do I need to do with those points? Join them where? Inside the square. So what I'm making is square number 2. Yeah, mine's a little bit off because I eyeballed it. I'm okay with that. Just a diagram. Like the plus sign and then, yeah. Then it says I have to repeat this, so I'm going to go to my new one and eyeball the midpoints of it. And what am I going to do with those points? Where? Inside the second one. So this is now square number 3. On tests, yes. Like jagged, nasty lines actually upset me because I'm left-brained and I don't like looking at them. And we are not barbarians. We use rulers. Square number 4. Like now it's getting kind of pretty. Who says art isn't mathy? Oh, Fibonacci. I love him. Did I have to start the original question with a square? Could we do this with other shapes? A hexagon? Could do it with a triangle. Could do it with an octagon. You notice this is kind of like square inception right now? Square in a square, in a square, in a square. Yeah, because it's fun. Look how pretty this is. Don't take away my fun. I am going to go until I run out of colors is really what I'm doing, because I'm doing each one a different color. Okay, even though I have an orange, I'll stop. Oh, I had purple, so I didn't use purple. Oh, I had black. Seriously, you just ruined my fun. Fun ruiner. That would be fun, but no, they said no. They blocked my fun. So, like, although that was pretty, we haven't actually done the question yet. That was just setting up the diagram. We got one number in the question. We got 1. The only number we have is what? What else do we need for our formula? We need R. We don't have R. What's the only way to find R? Is we need to get T2. How does T2 going to give me R? Because I'm going to divide them, right? So I need to find the perimeter of the next square in order to get T2. Okie dokie. Thoughts? Ooh, something with Pythagoras. I like where you're going there.
Oh yeah, you could find the length of the next square.
Well, before I find the next square, what do I need of this first square?
Well, just divide it by
I need the side length. And I could measure, but this is not drawn to scale. But I know the side length because the perimeter is 8. How can I find one side? Divide by 4. So what does one side have to be? 2. And that just came from 8 divided by 4 sides. I'm going to highlight this triangle up here. And there's no reason I chose that one. There are 4 of them. I just chose the one that happened to be at the top. Do I have the length from here to here? How do I know that it's 1? Because it's a midpoint, so I know this is 1. In theory, what does here to here at the top have to be? Also has to be 1 because every side is 2 and everyone has a midpoint. So I know those are 1 and 1. This is a right angle triangle. How do I know that? Because it's a square. By definition, it has to have a 90-degree angle. I can use this triangle to find the length of side of the second square. So I'm just going to redraw that triangle for visual people. I have 1 and I have 1, and I don't know that side right there. Ooh, explain. Except it's 1 squared plus 1 squared has to equal x squared. And so this is 2 is x squared. And then square root of 2 equals x. But, what did I tell you about every time you put a square root into an equation? Oh, but this is the one time it doesn't matter. And this is why we didn't talk about this in grade 8 when you first learned Pythagorean theorem, is because if it's a side length, could it be negative? No, so this is why we just don't ignore, we ignore that negative. So what it tells us from here to here is root 2. Okay, so what does the perimeter of the second square have to be? And if you don't like my notation, use words. Perimeter of the second square. 4, or square root of 2 plus square root of 2 plus square root of 2 square root of 2. So it has to be 4 times root 2. What can I do with this? 4 times root 2. Can I make that root 8? Perimeter of the second square. I heard I'm so confused. Back it up. Where are you unconfused? Do we understand where the root 2 came from? Okay, so 1 plus 1 is 2. And then how do you get rid of a squared? You square root it. So we figured out this side here is root 2. And then to find the perimeter, we just went root 2 plus root 2 plus root 2 plus root 2 is 4 root 2s. But can I do anything to simplify this? Can I multiply this, make it root 8? Really, radicals last year? Think about that. No, it's just 4 root 2. So don't try to do any fancy simplifying. It's just 4 root 2. So we know T2 is 4 root 2. It is quite the question. That's why I showed you this and not just said, here's for homework, have fun, children. Okay, what was the point of doing that? That's got to give us r. It's the only way to get r is to find T2. And so we know r is T2 divided by T1. And so this is 4 root 2 divided by 8. And so r equals... Don't calculator this. No, just look at the numbers. No. So 4 on the top, 8 on the bottom. If I took away the root 2, what would you reduce 4 on 8 by, or 2? Is a half. So this is going to be a half root 2, or root 2 divided by 2. The problem is if you plug that into your calculator, you can't round it off. That's why I want to keep it as an exact value. If you round here, your final answer is going to be off. Do you want to go to paper, or are you okay just finishing it here? Sum to infinity. T1 over 1 minus r. T1 is? R is? Root 2 on 2. If you have old operating system, you're going to have to put a bracket after the 2 when you're doing the root, and you're going to have to bracket the whole bottom. So I'll read it out for the old operating system people. You're going to put 8 divided, open bracket, 1 minus square root 2, and you'll notice it opened that bracket. That's what this is doing, is closing it off. So close, divide by 2, close. Is that rounded, or was there more after the 3? Okay, so rounded to 1 decimal place. Can we just confirm 27.3? Okay, so just try it again.
Divide by 0.
No dividing by 0.
Oh, I see.
So 8 divide, open bracket, 1 minus root 2, close bracket, divide by 2, close bracket. Jill, you probably don't know, you make the awesomest faces. When you don't understand something, it's awesome. Just looking for confirmation. Units. Units. Never would I expect you to look at a question like this having never seen it and be able to produce it. That's why we do an example. What's going to happen is either the shape will change or the question value will change. Instead of 8, it might be 16. Instead of 8, it might be 20. That's the only thing that's going to change. Process is going to always be this. So this was our step 1. This was our step 2. This was our step 3. That's why I showed you kittens, so you wouldn't freak out on that example.